What if I told you there's a planet where it rains molten glass sideways, where the sky is lit by two suns, and where an entire year passes in just 18 hours? These aren't scenes from a science fiction blockbuster, they're real places scattered across the universe, waiting to be discovered. Welcome to the extraordinary world of exoplanets, planets that orbit stars beyond our own solar system. These distant worlds are stranger than anything we could have dreamed up, and they're rewriting the rules of what we thought was possible in the cosmos. In this video, we'll uncover 22 jaw-dropping facts about exoplanets that will leave you questioning everything you thought you knew about the universe. From planets made of diamond to ones where the sun never sets, these discoveries aren't just fascinating, they're clues to understanding our own existence and the potential for life beyond Earth. So buckle up, because we're about to embark on a journey through the most mind-bending corners of space, where reality is stranger than fiction. Let's dive in. Imagine a planet so dazzling that its very surface could be a treasure trove of diamonds. Meet 55 Cancri, a world that sounds like it's been plucked straight from the pages of a science fiction novel. Located just 40 light-years away, this super-Earth is unlike anything in our solar system. Its carbon-rich composition means that beneath its scorching exterior, layers of graphite and diamond might stretch deep into its core. Scientists have even calculated its mind-boggling value at around $26.9 nonillion. To put that into perspective, a nonillion is a 1 followed by 30 zeros, a number so large it's practically beyond human comprehension. But 55 Cancri isn't just a cosmic jewel box, it's a window into the incredible diversity of planets out there. Most planets we know are made of rock, gas, or ice, but this one challenges that norm. Its existence suggests that planetary systems can form under wildly different conditions, giving rise to worlds that defy our expectations. What's even more fascinating is the possibility that this diamond planet isn't alone. If carbon-rich planets like this exist, what other unimaginable treasures might be waiting to be discovered? Could there be planets made of sapphire, gold, or even materials we've yet to identify? This glittering world also raises intriguing questions about how such planets form. Did 55 Cancri start as a carbon-heavy star that collapsed, or was it born from a swirling disk of carbon-rich dust? Either way, it's a reminder that the universe is full of surprises, and every discovery pushes the boundaries of what we thought was possible. So, while we may never set foot on this diamond-studded world, its very existence inspires us to keep exploring, to keep searching for the extraordinary hidden among the stars. Who knows what other wonders are waiting to be found? Imagine stepping onto a world where the sky is painted with not one, but two suns, casting shifting shadows and bathing the landscape in an ever-changing glow. This isn't a scene from a sci-fi movie, it's the reality of Kepler-16b, a gas giant that orbits a pair of stars, much like the iconic Tatooine from Star Wars. Discovered by NASA's Kepler mission, this exoplanet is a testament to the incredible diversity of planetary systems in our universe. Unlike Earth, which revolves around a single star, Kepler-16b experiences the unique phenomenon of double sunsets and sunrises, creating a celestial ballet that would leave any observer in awe. But how does a planet like this even exist? Binary star systems where two stars orbit each other were once thought to be too chaotic to host planets. Kepler-16b shattered that assumption, proving that planets can form and thrive in such dynamic environments. The gravitational interplay between the two stars and the planet creates a complex but stable dance, with Kepler-16b orbiting both stars in a wide, graceful loop. This discovery has opened up entirely new possibilities in the search for habitable worlds, as binary systems are surprisingly common in our galaxy. Now, the big question, could life exist on a planet with two suns? While Kepler-16b itself is a gas giant and unlikely to support life as we know it, its existence raises fascinating possibilities. Planets in binary systems might have unique conditions, such as extended periods of daylight or complex climate patterns caused by the dual stars. Some scientists speculate that life could find a way to adapt to these environments, perhaps in the shadows cast by the two suns, where temperatures might be more stable. The discovery of Kepler-16b has not only expanded our understanding of planetary systems, but also ignited our imagination about what might be possible in the cosmos. Who knows, the next habitable world we find might just have two sunrises to greet its inhabitants every day. Imagine stepping onto a planet where the skies aren't just a vibrant shade of blue, they're a warning. HD 189,733b, often called the lava world, is a place where the weather doesn't just defy expectations, it shatters them. This exoplanet, located 63 light-years from Earth, is a hot Jupiter, a type of gas giant that orbits perilously close to its star. But what makes this world truly otherworldly is its atmosphere, a chaotic brew of molten glass and hurricane-force winds. The winds here don't just blow, they scream across the planet at speeds of 5,400 miles per hour, turning silicate particles into razor-sharp shards of glass. These particles are whipped into a sideways storm, creating a phenomenon that's as beautiful as it is terrifying. The deep blue color of the planet might trick you into thinking it's a serene, Earth-like world, but don't be fooled. This is a place where the very air you'd breathe, if you could, would slice through you like 1,000 tiny knives. So how does a planet like HD 189,733b come to exist? It all starts with its proximity to its star. Orbiting just 3 million miles away, this planet is tidally locked, meaning one side perpetually faces the star while the other is trapped in eternal night. The temperature difference between the two sides creates a pressure imbalance, fueling those supersonic winds. The intense heat also vaporizes silicate minerals in the atmosphere, which then condense into droplets of molten glass. It's a cycle of creation and destruction happening on a scale that's almost impossible to comprehend. But beyond the spectacle, planets like HD 189,733b offer scientists a unique laboratory. By studying its extreme weather, we can better understand the atmospheres of other exoplanets, especially those that might seem impossible to explore directly. This fiery world reminds us just how diverse and dangerous the universe can be. And while it's not a place we'd ever want to visit, it's a vivid reminder of the incredible forces at work in the cosmos. Picture a world so scorching that it makes the surface of Venus seem like a chilly winter day. Welcome to Kelt 9b, a gas giant that shouldn't even exist. This planet orbits its star so closely that its surface temperature soars to a staggering 7,800 degrees Fahrenheit hotter than most stars in the universe. To put that into perspective, that's more than twice as hot as some red dwarf stars. But here's the kicker, Kelt 9b is not just surviving in this inferno, it's thriving, albeit temporarily. This extreme environment is so hostile that the planet's atmosphere is being blasted away by its star's relentless radiation. Imagine a cosmic sandstorm, but instead of sand, it's molecules and atoms being ripped from the planet's surface and flung into space. Scientists estimate that Kelt 9b is losing millions of tons of its atmosphere every second. It's like watching a planet slowly evaporate before our eyes. So how long can Kelt 9b hold on? Current models suggest it might only have a few million years left before it's completely stripped bare, a blink of an eye in cosmic terms. But its existence raises fascinating questions. How did it form in the first place, and what processes allow it to endure, even temporarily, in such an extreme environment? Kelt 9b challenges our understanding of planetary formation and resilience. It shows us that planets can exist in places we once thought impossible, pushing the boundaries of what we know about the universe. And while its fate may be sealed, its story offers a glimpse into the incredible diversity of worlds beyond our solar system, worlds that continue to surprise and inspire us. Imagine a planet where the entire surface is a vast, endless ocean, stretching as far as the eye could see, or at least as far as any spacecraft sensors could detect. Welcome to GJ 1214b, a super-Earth that's not just covered in water, but entirely dominated by it. This isn't your typical ocean world, though. Here, the water isn't just liquid, it's something far more exotic. Thanks to the planet's crushing atmospheric pressure and intense heat, scientists believe GJ 1214b hosts water in bizarre states we can barely imagine on Earth. Think hot ice, a form of water that stays solid even at high temperatures, or superfluid water, a liquid so slippery it defies the laws of friction. These strange forms of water aren't just hypothetical. They're the result of extreme conditions that make this planet unlike anything in our solar system. But what really sparks curiosity is the possibility of life. Could something survive beneath that thick, alien ocean? On Earth, we've found thriving ecosystems in the darkest depths of our oceans, near hydrothermal vents or buried under ice. If life can exist in those extreme environments, why not on GJ 1214b? The planet's global ocean could be hiding secrets we've yet to uncover, microbial life, or perhaps something even more complex. It's a tantalizing thought, one that reminds us how Earth's oceans are just one chapter in the story of water's role in shaping worlds. GJ 1214b challenges our understanding of what's possible, proving that the universe is far stranger and wetter than we ever imagined. What if a planet didn't belong to any star? It sounds like something straight out of a science fiction novel, but rogue planets are very real, and they're some of the most mysterious objects in the universe. Take SO-J 318, 522, for example, a planet that roams freely through the cosmos, untethered by the gravity of a star. Unlike Earth or Jupiter, which orbit the Sun, rogue planets like this one drift alone in the vast darkness of space, completely independent of any stellar system. So, how do these wandering worlds even exist? Scientists believe rogue planets could form in one of two ways. Some might have once been part of a solar system, only to be violently ejected by gravitational interactions with other planets or passing stars. Others could have formed on their own, collapsing directly from clouds of gas and dust without ever being tied to a star. Either way, their existence challenges our traditional understanding of how planetary systems come to be. But here's where it gets even more intriguing. Without a star to provide warmth, these planets are often freezing cold, shrouded in perpetual darkness. Yet, despite their harsh conditions, could they still harbor life? Some researchers speculate that beneath their icy surfaces, rogue planets might hide vast oceans kept liquid by internal heat from radioactive decay or tidal forces. If that's true, these lonely wanderers could be hiding secrets, perhaps even the building blocks of life, deep within their frozen cores. Rogue planets not only push the boundaries of what we know about the universe, but also force us to rethink the possibilities of life beyond Earth. They remind us that the cosmos is full of surprises, and sometimes the most fascinating discoveries are the ones we never expected to find. Imagine standing on a world where the sun hangs motionless in the sky, forever fixed in place. On one side of the planet, it's a blazing inferno, temperatures soaring so high that rocks might melt. On the other, an endless, icy night where the cold could freeze the air itself. This isn't science fiction, it's the reality of tidally locked planets like Proxima Centauri b. Because these planets are so close to their stars, gravity locks them in place, much like how the moon always shows the same face to Earth. One hemisphere is bathed in eternal daylight, while the other is shrouded in perpetual darkness. But here's where it gets fascinating. The thin strip of land between these two extremes, known as the Terminator Zone, might just be the Goldilocks region, not too hot, not too cold, where life could potentially exist. Picture standing in this twilight zone. The sun would hover on the horizon, never rising or setting, casting an eternal glow. It's a surreal thought, isn't it? Life here would adapt to a world without a day-night cycle. Plants might grow sideways, leaning toward the constant light, while creatures could evolve to thrive in the dim, stable conditions. But what would it mean for us as explorers or potential settlers? The challenges would be immense. On the day side, the heat would be unbearable, and on the night side, the cold would be deadly. The Terminator Zone, though habitable, would be a narrow ribbon of land, limiting space and resources. Still, the possibility of finding life, or even building a home, in such a unique environment is what makes these planets so captivating. Tidally locked worlds remind us just how strange and diverse the universe can be. They challenge our understanding of habitability and push us to think beyond the familiar rhythms of Earth. Could life exist in such extreme conditions? And if it does, what might it look like? These are the questions that keep astronomers and dreamers awake at night. Imagine a planet so light and airy that it feels like you could scoop it up with a spoon. Welcome to Kepler 51b, the cotton candy of the cosmos. This gas giant, often called a super-puff planet, has a density so low it challenges everything we thought we knew about how planets form. Picture a world where the atmosphere isn't just thick, it's downright fluffy, stretching out like a cosmic marshmallow. But here's the kicker. How does something so light even hold itself together? Kepler 51b is one of a rare breed of exoplanets that seem to defy the rules of physics. While most gas giants like Jupiter or Saturn have dense cores and heavy atmospheres, this super-puff planet is almost entirely atmosphere with barely any solid material at its heart. Scientists believe its low density might be due to an extreme buildup of hydrogen and helium gas, inflated by intense heat from its star. But that still leaves a big question. Why hasn't all that gas just floated away into space? One theory suggests that Kepler 51b might be relatively young, still holding onto its atmosphere before it has a chance to evaporate. Another idea points to its orbital distance far enough from its star that the solar winds aren't strong enough to strip it away. Whatever the reason, this planet gives us a glimpse into the early stages of planetary evolution, showing us that the universe is far stranger and more creative than we ever imagined. And here's where it gets even more fascinating. Studying super-puff planets like Kepler 51b could help us understand how atmospheres form and evolve, not just on distant worlds, but even here in our own solar system. It's like finding a cosmic laboratory, one that challenges our assumptions and pushes the boundaries of what we thought was possible. So, the next time you look up at the stars, remember, out there, somewhere, there's a planet as light as a dream, floating through the void, holding secrets we've only begun to uncover. Picture this, a planet so close to its star that it's literally being stretched and pulled apart, like a piece of taffy in the hands of a cosmic giant. That's WASP-12b, a hot Jupiter exoplanet locked in a deadly dance with its host star. This isn't just a planet, it's a cosmic tragedy unfolding in real time. WASP-12b orbits so tightly that its star's intense gravity warps it into an egg shape, and its atmosphere is being ripped away, forming a comet-like tail that trails behind it. It's a planetary death spiral, and it's happening right now, over 1,000 light-years away. What makes WASP-12b so fascinating isn't just its doomed fate. but what it reveals about the universe's cycle of creation and destruction. Stars don't just nurture planets, they can also destroy them. In the case of WASP-12b, the star's gravitational forces are so strong that they're stripping away the planet's atmosphere, bit by bit, and flinging it into space. Over time, this process will leave nothing but a barren core, a ghost of what once was a thriving gas giant. But it's not just about destruction, it's about transformation. The material being ripped from WASP-12b's atmosphere is feeding its star, creating a cosmic recycling system. This violent interaction is a reminder that even in the vastness of space, nothing is static. Planets are born, they evolve, and sometimes they meet dramatic ends. WASP-12b's story is a glimpse into the chaotic, unpredictable nature of the universe, where even the mightiest planets are at the mercy of their stars. And here's the kicker: WASP-12b's fate might not be unique. Scientists believe this process could be happening to other planets across the galaxy, giving us a front-row seat to one of the universe's most dramatic phenomena. So, while WASP-12b may be doomed, its story is far from over. It's helping us understand the complex, often violent relationship between stars and the planets that orbit them. Imagine a planet where the ground beneath your feet isn't solid rock but a vast, bubbling sea of molten lava. That's Co-Rho T7b, a scorching exoplanet that defies our understanding of rocky worlds. Located about 489 light-years away, this alien world is so close to its star that its surface temperatures soar to nearly 4,000 degrees Fahrenheit, hot enough to vaporize rock and create oceans of lava. But what makes Co-Rho T7b truly fascinating isn't just its hellish conditions. It's the fact that this planet is one of the densest rocky worlds ever discovered. Scientists believe its high density points to a composition rich in iron, a characteristic that sets it apart from most terrestrial planets we know. This iron-heavy makeup raises intriguing questions about how such a planet could form. On Earth, iron is largely concentrated in our core, but Co-Rho T7b's surface might be brimming with this heavy metal. Could this mean that the planet's interior has been stripped away, leaving behind a dense metallic shell? Or does it hint at a unique process during its formation, where iron played a much larger role than in planets like ours? Studying Co-Rho T7b could shed light on the diversity of planetary compositions and the extreme conditions under which terrestrial worlds can evolve. What's even more mind-boggling is the idea that this lava-drenched, iron-rich world might hold clues to the early stages of planet formation. If Co-Rho T7b is a remnant of a once larger planet that lost its outer layers due to intense stellar radiation, it could act as a time capsule, preserving secrets about how rocky planets are born and shaped. Its extreme environment challenges us to rethink what's possible in the universe, reminding us that the cosmos is far stranger and more varied than we could ever imagine. Now picture this, a ring system so enormous that it makes Saturn's iconic rings look like a thin piece of thread. Meet J1407b, a gas giant located about 434 light-years from Earth, with a ring system that's 200 times larger than Saturn's. To put that into perspective, if J1407b were in our solar system, its rings would stretch farther than the distance between Earth and the Sun. Just try to imagine looking up at the night sky and seeing rings so vast they eclipse everything else. It's a sight that would redefine our understanding of beauty in the cosmos. But how does a planet end up with such a colossal ring system? Scientists believe that J1407b's rings are likely the remnants of a moon-forming disk, similar to the way planets form around young stars. Over time, the material in the disk could have clumped together, forming moons, while the rest of the debris stayed in orbit as rings. What makes J1407b so fascinating is that its rings are still evolving. giving us a rare glimpse into the early stages of planetary and lunar formation. It's like a cosmic time capsule frozen in the act of creating new worlds. What's even more intriguing is what these rings tell us about the planet itself. The sheer size of the ring system suggests that J1407b is either incredibly massive or has a unique gravitational influence that keeps such a vast amount of material in orbit. Some researchers speculate that the planet might even have moons embedded within its rings, slowly shaping and sculpting them over time. This interplay between a planet, its rings, and potential moons could hold the key to understanding how solar systems like ours come to be. So, while Saturn's rings are stunning, J1407b's ring system is on an entirely different scale, both in size and scientific significance. It challenges our assumptions about planetary systems and reminds us that the universe is full of surprises waiting to be discovered. And who knows, studying J1407b might just help us unlock the secrets of how planets and moons form, not just in distant star systems, but right here in our own cosmic backyard. Imagine a world where a single day feels like an eternity, but an entire year passes in less time than it takes to binge your favorite TV series. That's Kepler-78b, a planet so close to its star that it completes an orbit in just 18 hours. To put that in perspective, a year on Earth is about 8,760 hours long. On Kepler-78b, you'd celebrate a birthday every 18 hours, though you probably wouldn't want to stick around for the party. This planet is a true extreme in the exoplanet catalog. Its surface temperatures soar to around 2,000 degrees Celsius, hot enough to vaporize rock and turn it into a molten lava ocean. Astronomers often compare Kepler-78b to a cosmic version of Dante's Inferno, where the relentless heat and gravity create a hellish environment that defies our understanding of planetary formation. But how does a planet even survive in such a hostile zone? Kepler-78b's existence challenges our theories about how planets form and evolve. Typically, planets are thought to form farther out in a star system and then migrate inward over time. But Kepler-78b orbits so close to its star that it's practically skimming the surface. This raises questions about how it avoided being torn apart by the star's gravity or consumed entirely during its migration. This fiery world also offers a unique window into the limits of habitability. While Kepler-78b is far from being a candidate for life as we know it, studying its extreme conditions helps scientists understand the boundaries of where life could potentially exist. If a planet can survive in such an intense environment, what does that mean for other worlds in the universe? Could there be planets orbiting stars even closer, pushing the limits of what we thought was possible? Kepler-78b is a reminder that the universe is full of surprises, and sometimes the most extreme places can teach us the most profound lessons about the nature of planets and perhaps even life itself. Now let's dive into one of the most bizarre and fascinating exoplanets ever discovered, HD 189733b. This world is a true oddity, not just because it rains glass sideways in its scorching winds, but also because of its methane-rich atmosphere. Imagine standing on this planet. If you could survive the extreme conditions and looking up to see a sky tinged with a deep, eerie blue. That blue hue isn't just for show, it's caused by methane molecules scattering light, much like how Earth's atmosphere scatters sunlight to create our familiar blue sky. But here's the twist: on HD 189733b, the methane isn't just a passive backdrop, it's a key player in shaping the planet's wild and hostile environment. Methane is a gas we associate with Earth swamps or even the frozen lakes of Titan, Saturn's moon. But on this exoplanet, methane creates an entirely different kind of atmosphere, one that's thick, turbulent, and possibly filled with organic compounds. Scientists believe this methane-rich environment could be a window into understanding how complex chemistry evolves on distant worlds. Could there be other planets out there with even more exotic atmospheres? Absolutely. Some might have atmospheres dominated by ammonia, sulfur, or even metallic vapors, conditions that would make HD 189,733b seem almost tame by comparison. What's truly mind-boggling is how these atmospheres can reshape our understanding of planetary science. Methane, for instance, is often considered a potential biomarker, a sign of life on Earth-like planets. But on HD 189,733b, it's a reminder that methane can thrive in environments utterly hostile to life as we know it. This raises an intriguing question. How many other worlds out there are hiding atmospheres we can barely imagine? The diversity of exoplanet atmospheres is a testament to the universe's endless creativity, and HD 189,733b is just one piece of that cosmic puzzle. Now, picture a planet that doesn't follow the rules. Fomalhaut b is one such rebel, tracing a path so wild it could easily be mistaken for a comet. This exoplanet doesn't orbit its star in a neat, circular path like Earth does. Instead, it follows an eccentric, elongated orbit that takes it incredibly far from its host star before whipping back in a dramatic, high-speed swoop. It's almost as if Fomalhaut b is dancing to a chaotic rhythm, defying the orderly patterns we often associate with planetary systems. But what could cause such a bizarre orbit? Astronomers believe this erratic path is the result of gravitational tugs of war with other massive objects in the system. Imagine a cosmic game of billiards where planets and debris collide, scatter, and pull at each other over millions of years. Fomalhaut b's wild journey might be the aftermath of such gravitational chaos, a snapshot of a system still settling into its final arrangement. This raises a fascinating question. How common are these chaotic orbits in the universe? While our own solar system appears relatively stable, Fomalhaut b reminds us that not all planetary systems are so serene. Its comet-like path offers a glimpse into the turbulent processes that shape these systems, where collisions, close encounters, and gravitational nudges can send planets spiraling into extreme orbits. Studying worlds like Fomalhaut b helps us understand the dynamic, often unpredictable nature of how planets form and evolve. And here's the kicker: this planet's unusual orbit might not last forever. Over time, gravitational forces could stabilize its path, or perhaps fling it out of the system entirely. Fomalhaut b is a reminder that planetary systems are living, breathing entities, constantly changing and adapting, a far cry from the static, picture-perfect models we sometimes imagine. Now let's turn our attention to WASP-18b, a planet that defies expectations in the most dramatic way. Imagine a world where the air itself is poison. This exoplanet, located about 400 light-years away, has an atmosphere dominated by carbon monoxide, a gas that's lethal to most life as we know it. For humans, even a small amount of this gas can be deadly, but on WASP-18b, it's the primary component of the air. This discovery isn't just fascinating, it's revolutionary. It forces us to rethink everything we thought we knew about atmospheric chemistry and the potential for life beyond Earth. What makes WASP-18b so unusual is that carbon monoxide is typically a trace gas in planetary atmospheres. On Earth, it's produced by incomplete combustion, think car exhaust or forest fires, but it never accumulates in large amounts. On WASP-18b, however, carbon monoxide isn't just present, it's the star of the show. Scientists believe this could be due to the planet's extreme heat, which prevents the gas from breaking down or reacting with other elements. The result? An atmosphere that's as toxic as it is intriguing. This raises a provocative question: could life exist in such a hostile environment? While carbon monoxide is deadly to humans and most Earth-based organisms, there are extremophiles on our planet that thrive in conditions once thought uninhabitable. Deep sea vents, acidic hot springs, and even radioactive environments are home to microbes that push the boundaries of what we consider life-friendly. Could similar organisms adapt to a carbon monoxide-dominated world? It's a tantalizing possibility, and one that challenges us to expand our definition of habitability. The discovery of WASP-18b also highlights just how diverse exoplanet atmospheres can be. We often assume that planets in other solar systems will have atmospheres similar to Earth's, dominated by nitrogen and oxygen, but WASP-18b shatters that assumption. It's a reminder that the universe is full of surprises, and that the ingredients for life, or at least the conditions that might support it, could be far more varied than we ever imagined. As we continue to study WASP-18b and other exoplanets like it, we're not just learning about distant worlds, we're learning about the fundamental principles of planetary science. Each discovery challenges our assumptions and opens up new possibilities, reminding us that the cosmos is far stranger and more wondrous than we could have ever imagined. Picture a world where a single year lasts longer than the entire span of human history. HD 106906b, a colossal gas giant, takes an astonishing 15,000 years to complete just one orbit around its star. To put that into perspective, if you were born on this planet, you'd never live long enough to witness even a fraction of its year. This isn't just a quirky fact, it's a cosmic puzzle that challenges everything we think we know about how planets form and where they can exist. HD 106906b is located so far from its star that it defies the typical models of planetary formation. Most planets we've discovered orbit relatively close to their stars, following the patterns we see in our own solar system. But this gas giant is an outlier, drifting in the cold, dark outskirts of its system. Its vast orbit raises intriguing questions. How did it end up there? Was it flung outward by some ancient gravitational tug of war, or did it form in place, defying the odds? What makes HD 106906b even more fascinating is what it tells us about the outer edges of star systems. Beyond the familiar orbits of planets like Earth or Jupiter, there's a mysterious frontier where the rules of planetary formation seem to bend. Could there be more worlds like this lurking in the shadows of their stars, and what else might be hiding in those uncharted regions? This distant planet is more than just an oddity. It's a window into the extremes of the universe, pushing the boundaries of what we thought was possible. As we uncover more about HD 106906b and others like it, we're reminded that the cosmos is full of surprises, waiting to challenge our assumptions and expand our understanding. Picture a world where the sky never fully darkens, where the atmosphere itself glows with an eerie, otherworldly light. That's WASP-76b, a planet so extreme it makes even the wildest sci-fi fantasies seem tame. This hot Jupiter, located roughly 640 light-years from Earth, is tidally locked to its star, meaning one side is perpetually scorched by sunlight while the other remains in eternal darkness. The day side reaches temperatures so blistering over 2,000 degrees Celsius that metals like iron vaporize into the atmosphere. But here's where it gets even stranger. As these iron vapors drift to the cooler night side, they condense and fall as molten metal rain. It's a planet where the sky quite literally rains liquid iron, a phenomenon so bizarre it's hard to wrap your head around. But WASP-76b's glowing atmosphere isn't just a spectacle, it's a window into the incredible diversity of exoplanets. Scientists believe this glowing effect is caused by the intense heat radiating from the planet's day side, creating a permanent twilight zone where the atmosphere emits a faint reddish glow. This kind of extreme environment challenges our understanding of planetary atmospheres and raises an intriguing question: how many other glowing worlds might be out there, hidden in the vastness of space? Could there be planets with atmospheres that shimmer in ultraviolet or glow in colors we can't even imagine? The possibilities are as endless as the universe itself. What's truly fascinating is how WASP-76b pushes the boundaries of what we thought was possible. It's not just a planet, it's a laboratory for studying the behavior of matter under extreme conditions. By observing worlds like this, we gain insights into the physics of high-temperature atmospheres and the complex interactions between a planet and its star. And while WASP-76b might seem like a one-of-a-kind oddity, it's a reminder that the universe is full of surprises, each one more extraordinary than the last. So, as we gaze at the stars, let's keep wondering, what other glowing, molten, or downright bizarre worlds are waiting to be discovered? Imagine standing on the surface of a distant world, gazing up at not one, not two, but three suns hanging in the sky. This isn't science fiction, it's the reality of Kelt 4ab, a gas giant that orbits one star in a triple star system. The sight of a triple sunset would be nothing short of breathtaking, with each star casting its own unique glow across the horizon. But beyond the sheer beauty of this phenomenon lies a fascinating question. How does a planet like Kelt 4ab even exist in such a chaotic environment? Multi-star systems are already rare, but planets within them are even rarer. The gravitational dance between three stars creates a complex and ever-changing environment, making it incredibly challenging for planets to form and survive. Yet, Kelt 4ab defies the odds, orbiting its primary star while the other two stars circle each other in a distant embrace. Scientists believe that planets in these systems might form farther out, where the gravitational tug of war is less intense, and then migrate inward over time. But survival in a triple star system isn't just about formation, it's also about stability. The gravitational forces at play could easily fling a planet out of its orbit or tear it apart entirely. Kelt 4ab, however, seems to have found a delicate balance, holding its ground in this cosmic ballet. This raises even more questions. How do planets adapt to such extreme conditions? Could there be other worlds like Kelt 4ab, thriving in the chaos of multi-star systems? What's truly remarkable is how discoveries like these challenge our understanding of planetary formation. Kelt 4ab isn't just a scientific curiosity, it's a window into the incredible diversity of the universe. As we uncover more about these rare systems, we're reminded that the cosmos is far stranger and more wondrous than we ever imagined. And who knows, maybe one day we'll find a planet like Kelt 4ab with conditions just right for life, proving that even the most chaotic corners of the universe can hold surprises. Now picture a world where the skies aren't filled with nitrogen and oxygen like ours, but instead a swirling mix of hydrogen and helium, the very elements that power the sun. That's exactly what scientists found on HATP 11b, a Neptune-sized exoplanet with an atmosphere unlike anything we've seen in our own solar system. This isn't just a quirky detail, it's a discovery that flips the script on what we thought we knew about gas giants. Hydrogen and helium are the lightest and most abundant elements in the universe, but finding them dominating an exoplanet's atmosphere in such a way forces us to rethink how these planets form and evolve. Could this be a common trait among distant worlds, or is HATP 11b a rare outlier? What makes this even more fascinating is the comparison to our own solar system. Neptune, for instance, has a hydrogen-helium atmosphere too, but it's mixed with methane and other heavier compounds. HATP 11b, on the other hand, seems to have a much purer, sun-like composition. This raises a tantalizing question. Why do some planets hold onto these lighter elements while others don't? Could it be due to their distance from their star, their size, or even their age? Each new discovery like this one adds another piece to the puzzle, showing us just how varied and unpredictable the universe can be. And here's the kicker: HDP-11b isn't just a scientific oddity. It's a window into the incredible diversity of exoplanet atmospheres. If this planet can defy expectations, what else might be out there? Could there be worlds with atmospheres made of exotic gases we've never even imagined? Or perhaps planets with layers of atmosphere so complex they create weather patterns unlike anything we've seen? Every time we peer into the skies of these distant worlds, we're reminded that the universe is full of surprises just waiting for us to uncover them. Imagine a world where you could celebrate New Year's Day every 20 hours, not because you're impatient, but because the planet you're on completes an entire orbit around its star in less time than it takes Earth to spin once. Welcome to Kepler-10b, a rocky exoplanet that defies everything we know about time and planetary motion. Its year lasts just 84 Earth days, making it shorter than its own day. That's right, on Kepler-10b, a year is over before a single day has even passed. This mind-bending phenomenon happens because Kepler-10b orbits incredibly close to its star, completing laps at breakneck speed. Picture a sprinter running endless laps around a track, never slowing down. The planet's proximity to its star means it's scorching hot, with surface temperatures reaching thousands of degrees Celsius. But the extreme orbit doesn't just affect the heat, it also creates a gravitational tug of war between the planet and its star, stretching and compressing the planet's surface like cosmic taffy. What does this mean for the planet's climate and geology? Well, with such a short year, Kepler-10b likely experiences extreme temperature swings. One side of the planet might be permanently facing the star, locked in a searing inferno, while the other side could plunge into icy darkness. This constant tugging and heating could also trigger intense geological activity, like volcanic eruptions or tectonic shifts, reshaping the surface over and over again. Kepler-10b challenges our understanding of what a planet can be. It's a reminder that the universe doesn't play by Earth's rules. Orbits can be wild, temperatures extreme, and time itself can feel like it's speeding up or slowing down depending on where you are. As we discover more worlds like this, we're forced to rethink the very definition of a planet and the limits of where life, if it exists, might thrive. Now picture a world where the ground beneath your feet is constantly reshaping itself, not through the slow drift of tectonic plates, but in a fiery, explosive dance of volcanoes. This isn't science fiction, it's the reality of exoplanets like T7b. This distant world, orbiting perilously close to its star, is a seething cauldron of volcanic activity, earning it the nickname the lava planet. Its surface is a patchwork of molten rock and towering volcanic peaks, a landscape that feels more like a scene from a fantasy epic than a real place in the universe. But what makes this kind of world so fascinating isn't just its spectacle, it's what it reveals about the forces that shape rocky planets like our own. T7b's extreme volcanic activity is driven by its tight orbit, which creates intense gravitational forces. These forces stretch and squeeze the planet, generating enough internal heat to keep its surface in a constant state of eruption. It's a process known as tidal heating, and it's the same phenomenon that powers the volcanic moons in our solar system, like Jupiter's fiery moon Io. But while Io is fascinating in its own right, T7b takes this fiery drama to a whole new level. Its surface temperatures can soar to thousands of degrees, hot enough to vaporize rock and create an atmosphere of silicate vapor. Imagine standing on a planet where the sky itself is made of the same material as the ground beneath you, a surreal and otherworldly experience. What's truly remarkable about these volcanic worlds is what they can teach us about the early history of planets like Earth. Billions of years ago, our own planet was a hot, molten mess, its surface riddled with volcanoes and lava flows. Studying exoplanets like Co-Rho T7b gives us a window into that turbulent past, helping us understand how rocky planets cool, solidify, and eventually become habitable. It's a reminder that the calm, stable Earth we know today was once as wild and chaotic as these distant worlds. And while Co-Rho T7b is far too extreme to support life as we know it, its fiery nature offers clues about the conditions that might exist on other, more temperate rocky planets. So, the next time you look up at the night sky, think about the volcanic exoplanets out there. Their surfaces constantly remade by fire and heat. They're not just distant curiosities, they're time machines offering us a glimpse into the fiery birth of worlds, including our own. Imagine standing on a distant world, gazing up at a sky filled with swirling orange clouds. But here's the twist: instead of water droplets, this alien rain is made of methane. Sounds like something straight out of a sci-fi movie, right? Well, this isn't fiction, it's a real possibility on some exoplanets, particularly those resembling Saturn's moon, Titan. These Titan-like worlds, like those in the TRAPPIST-1 system, could have methane rain that fills lakes and rivers, creating a landscape that mirrors Earth's water cycle, but with a bizarre, otherworldly twist. What makes these methane cycles so fascinating is how they parallel our own planet's hydrologic system. On Earth, water evaporates, forms clouds, and falls as rain, sustaining life as we know it. On these exoplanets, methane plays the same role, evaporating, condensing, and raining down to shape the surface. But here's the kicker: while water is essential for life on Earth, could methane serve a similar purpose in these alien environments? Scientists are actively exploring whether life could adapt to thrive in such radically different conditions. The TRAPPIST-1 system, in particular, is a hotbed for this kind of speculation. Its planets are rocky, Earth-sized, and lie in the habitable zone, meaning they're at the right distance from their star to potentially support liquid on their surfaces. But instead of water, it could be methane pooling in vast lakes or flowing in rivers. This raises a tantalizing question: could life evolve to use methane as its lifeblood, just as Earth's organisms rely on water? Of course, the chemistry of life as we understand it is built around water, but the universe has a way of surprising us. If life exists on these methane-rich worlds, it might look nothing like anything we've ever seen. It could be built from entirely different molecules, thriving in conditions that would be lethal to Earth-based organisms. The idea of a methane-based biosphere challenges our assumptions about what life requires, and opens up thrilling possibilities for discovering truly alien forms of existence. So, while we can't yet say for sure whether these Titan-like exoplanets host life, they serve as a reminder of the incredible diversity of worlds out there. From rain made of methane to lakes that shimmer with a golden hue, these distant planets blur the line between science and science fiction, inviting us to rethink what's possible in the cosmos. From diamond-studded worlds to planets where the sun never sets, exoplanets have proven to be a treasure trove of cosmic wonders that defy our imagination. These 22 facts are just a glimpse into the extraordinary diversity of the universe, reminding us that reality often surpasses even the wildest science fiction. Each discovery challenges our understanding of what's possible, pushing the boundaries of how we see not just distant stars and planets, but our own place in the grand tapestry of existence. As we continue to explore these alien worlds, we're not just learning about them, we're learning about ourselves. Every new exoplanet discovered raises questions about the origins of life, the conditions needed for it to thrive, and whether we're truly alone in the cosmos. The more we uncover, the more it feels like we're just scratching the surface of a universe brimming with mysteries waiting to be solved. So, what's next? With advanced telescopes and groundbreaking technologies on the horizon, the future of exoplanet exploration is brighter than ever. Who knows what kind of worlds we'll find next, perhaps one with oceans of liquid metal, or another with skies that shimmer like rainbows. The possibilities are as infinite as the universe itself. What are your thoughts on these incredible discoveries? Which exoplanet fact blew your mind the most? Let us know in the comments below. We'd love to hear your take on the wonders of the cosmos. And if you're as fascinated by these cosmic adventures as we are, make sure to hit that subscribe button and join us for more journeys into the stars. Until next time, keep your eyes on the skies and your curiosity alive. The universe is waiting to surprise us all.